Okay, YouTube, in this video we're going to set out to sketch an ellipse given by an equation. The only thing here is the ellipse that we're given the equation of has its equation in what we call general form. And that is, general form is all of our variable terms on the left and just set equal to 0 on the right. So what we're going to want to do is we're going to rewrite this into the standard form of the equation for an ellipse. And recall that the equation of an ellipse is just like an altered equation for a circle where we have an x squared term, a y squared term, they're being added together and this all equals 1, but we say that they're being divided by two different quantities, and so that's what causes it to be non-circular. So this is our standard form of the equation of this ellipse, where we have the center is being given at always h and k, and we say that a is our semi-major axis length and b is our semi-minor axis length. Okay. So that being said, we basically just want to know these things, and we're going to be able to find that out. We just need to rewrite this way first. So part of this video is just kind of practice on how you would do this, and what we're going to do, I'll just tell you, is complete the square. But we're going to need to do this for both our x term and our y term. So the first thing I want to do is I want to reorganize our expression here. We say x squared plus 6x. Let's put our x's together. We say plus 4y squared minus 8y. And then the last thing I'm going to do is I'm going to take this constant 9. I'm going to boot that to the other side. The thing I want to do when we complete the square, recall, is this. We want to say, well, I've got x squared plus 6x plus, now what could I add for a constant that would cause this to be a perfect square binomial? The rule is it's always half of the middle term squared. Now, that's only true if your leading coefficient on your squared term is 1. In this case, it is. So we could say that I really get this. I get x squared plus 6x plus, what would I really want in here? I would really want half of 6 squared, which is 3 squared, which is 9. And then over here, you notice that your leading coefficient is not 1. So this means we're actually going to have to factor that out front first and get left with this on the inside. But I'd say, well, then really, what would I want to have here instead? And I can answer this now that this is a 1. We could say half of negative 2 is negative 1. Negative 1 squared is 1. So I'm going to put a 1 there. So we've basically completed the square now for both x's and y's. We just need to add what we added to the left to the right. So I added a 9 to the left, and you would say, well, I added a 1 to the left also, so I'm going to add a 1. Technically, we added 4 times 1 to the left, so we have to add a 4 here also. So cleaning this up a bit now, we get x, and this would be plus a 3 squared, since this is half the middle term there, and this is a perfect square trinomial, factors into a perfect square binomial. We say, well, plus 4 times now y minus 1 squared, and this equals, well, it looks like a 4. So we're almost in standard form for the equation of an ellipse. It's just that we need to divide everything by whatever's on the right to make that purposefully into a 1. So we get now a 1 on the right. On the left, we just get left with this. We get x plus 3 quantity squared over 4. And we say plus now, 4 and 4 here cross cancel. I get left with y minus 1 quantity squared. So you'll see it written this way sometimes. I'm actually going to encourage everybody to put a 1 underneath. And actually, we could say that this is our bigger of the two numbers, so that must be our a squared, and this is our b squared here. So keep in mind, the things we needed were the center. So we could say the center of this ellipse now is at h and k, so our h value is negative 3, k value is here 1. So we say left 3 up 1, this is the center of our ellipse, and then we say, well, our a squared. Now a squared equals 4, so a, in this case, equals 2. And we say that b squared, which is equal to 1, we say b must be 1 also. So we say that since our bigger of the two numbers was underneath the x-termed thing, we say that we're going to go 2 each way, but in a horizontal sense. So this is our major axis here, and then our minor axis runs the other way. We say go 1 above the center, 1 below the center. So here's our elliptical thing right there. We don't need to find the foci on this one. We weren't asked to, but that's how you would graph an ellipse, by putting it into standard form first. Cheers.